everybody. Welcome to another exciting, hair-raising, fun-filled, expeditious episode of Radiorama, where I show you how to work on radios, television, stereo systems, who knows what else. Today I'm going to start the episode showing kind of what are some of the most common capacitors I order. I didn't order everything that I use because I was low on just some values, but typically what I order, starting at the top as electrolytics goes, 47 microfarads at 160 volts DC, that is for your hot chassis sets. 47 microfarads, 450 volts, that's for the transformer sets. I also use 10 and 20 microfarad caps, but I already have a bunch of those. Then for some of the portable hot chassis sets and some FM sets, I'll buy a whole bunch of 100 microfarad, 160 volt caps. Now, as far as the polarized caps, I order 0.0047, 0.01, 0.022, 0.033. This is the most common that I order all the time. 0.047, 0.068, and 1/10 of a microfarad. And I order them from Sal's Capacitors, and he's quick and his prices are good. And usually if I order on a Monday, it seems like I get them on like a Wednesday or Thursday, so he's good with his shipping. So I'm going to restock my cabinets, and then we'll get to the radio at hand, which is a 1937 Sears Silvertone model 4500, known also as the Streamliner. Working condition is unknown. The cord has been cut. It looks like it's not been worked on in quite a while due to all the accumulated filth. I think I worked on this model maybe 10 years ago. It is a transformered set. I looked up the tube lineup. It is definitely not a filament. Not a filament string set, which is good. So I'll put these away, and then we'll take this apart, and we'll see what's going on underneath. All right, so we got it apart, and it's been worked on actually quite a bit. First thing I did is I checked, see if the speaker's rubbing anywhere. It's not. It's going in and out without making a noise. That's good. I don't think that's original. Someone replaced this. This is an electrolytic. It has two 8 microfarad electrolytic capacitors. It's a field coil speaker, obviously. And when I look under here, there's all different eras of capacitors. To me, it looks like there's not a single original capacitor left in here. This, that, and that are all replacements. Probably from, looks like you got a mixture of capacitors from the 40s through 50s. This is a replacement. I don't know about that. That might be original, and so too might this one. But the rest of these, I believe, are maybe that's original to the set. That certainly ain't. That's a different era, and so is this. And we got another cap underneath that. Looks like someone added either it's a headphone jack or a jack for a record player. I don't know. Here's the transformer, and this is something weird I've not seen before. The transformer apparently also doubles as a mount for one of the RF coils. And looks like we have one coil here, and some other coil here, but I don't think that's an IF or RF transformer. So it's probably not a super sensitive set. It's just a 5-tube set, and it's got this tube on the end that I'm not familiar with. It says 1V. Makes me wonder if it's actually a ballast tube. Let's see what's going on in there. No, it's not a ballast tube. It's definitely something for picking up something. Of what? Probably radio signals. Good guess. Get back in there. I don't know what we got on this side here. This is either the rectifier. You know what I bet? I bet that is probably either the output or the rectifier. Oh, come on, get out of there. What are you? 43. I have to look that up. I think that actually might be the output. I'm not as familiar with my big pin tubes as I am my octals and loctals, since I work on that era a lot more than this era. So I am going to look it up and see what comes up, assuming I can get it back in the damn case here. There we go. So there you have it. It's been well used and well loved, and clearly someone put a lot of time keeping it running. That's what I kind of like to see. It's a radio that's been in a lot of use. Okay, so I did look it up. This is the rectifier. It's a half-wave rectifier. This is the output tube, and this is the 3 IF RF related tubes. I think there's a 66, maybe 2 66s and a 6F6. Wouldn't be a 6F6, that's an output tube. I didn't look at what the tubes are because I'm lazy, but whatever. Now it's going to be time to start doing the bare basics, which is I would not dare plug this in. All of these electrolytics are probably shot. In fact, there's one here. There's more than one here that are oozing its guts. Like this guy has bulging happening on the ends here. This guy has some bulging. With the transformer set, if you have some shorted components, you'd run a good potential risk of taking out your power transformer here. And you don't want to do that because this is probably a real special weird size. Plus it has that RF transformer stuck to the top of it. So making a new one work there would be no easy feat at all. All right, so I yanked the this box off of there. You can tell this was added later because you see the rivets from the original. Probably it was a tubular capacitor. You can see the circular outline when it kind of came up this way. These were probably red at one point, and they've of course faded to nothing. These are black. These are probably the ground. Probably goes to chassis ground. But from now, I'm just going to cut it out of there. Kind of curious what's inside that box, actually, what it looks like. Maybe later we'll do some investigating. Anyway, we'll replace both of those with 2 of these, and I want to probably push these back in, and we'll just mount them underneath because these are so small. Yes, they bounce up and down. They're happy. We can fit them underneath here and make it a little neater looking. Well, in order to replace those 2, I'm going to have to get some stuff out of the way. I'm going to have to replace this guy, which is a 16 microfarad at 450. This is another electric. Why is there so many electrolytics in this thing? 1, 2, for up top, 3, 4, 5, 6 electrolytics. That is bizarre. There's more electrolytics than there are paper caps. Because there's only 1, 2, 3, 4 paper caps. So some very strange, funny engineering that I don't quite understand going on in here. I'm not an engineer, so I'm sure some of you guys who are will be like, I know why. It's because of XYZ. Go ahead, let me know. But I need to clean some space out here so I can push these other wires back in. Before I replace them, I'm also curious that sometimes if people needed a, say like an X number of value and they only had like 1 value on hand, like it says it calls for 2 8 microfarad caps. It could very well be a single 20 microfarad caps, and they just put the 2 capacitors in the box together to give you double that capacitance. We'll see. Once I clear all this crap out of there, we'll see what's going on underneath there. All right, so I've cleared out a lot of stuff here, and now we can see what's going on. These 2 former 8 microfarad leads do go to individual places. This one comes off of, what is that? On big pins, you start with the fat pins and work your way around. So that's pin number 4 of the rectifier, is one of these electrolytics. This other one is going to a whole bunch of shit. That's probably going into the field coil. And what is this one doing? This is coming off of pin number 1, 2, 3, 4, 5, 6 of one of the receiving tubes. Again, I'm being super non-technical here. But I'm going to replace these 2 down here, and these 2, and then we're going to bring it up slowly on a variac and see if we have any life in it. Alright, so we got all the electrolytics replaced. Like I said, I'm not really sure why there's so many on this. So now it's time to, oh, one other thing, I replaced the cord. Here's a little trick I've learned. If you don't want the cord to chafe on the metal, I put a little rubber grommet there so it's not going to rub. So now it's turned upright. I've got it hooked up to my Variac. And let's see, is it on? Yes, it's already on. It's going to turn up just a little bit. Let's go ahead and bring it up slowly. It doesn't have a pilot light on this guy, so I'll not have any indication whether it's on for a little while. Actually, I did clean the tubes off. I'm going to start looking for filament. Started off with about 50% and see if we have any life. Of course we won't. That's not enough to really do anything. I'm just listening and smelling for something funny. Bring it up just a little bit more, maybe about 70%. Okay, I'm starting to see some filament showing up in the output tube and the rectifier. Of course, the rest of these guys are capped. Bring it up just a little bit more.
And a fresh start for those struggling with addiction or personal crisis. A Bay Area rescue mission delivers the hope of the gospel.
IRS Commissioner Charles Reddick recently.
Well, your partnership with the Bay Area Rescue Mission helps meet the
32, right? Ends meet. That's according to a new survey.
Doesn't your child deserve an effective motive that lines up with
Emeryville as you continue on westbound, eastbound, making your way towards...
Yeah, good radio. That's not even with all the capacitors replaced. That's a real promising sign. Didn't smell anything. Didn't see anything. Nothing blew up. Let's see. Transformer's nice and cool. If something was going to be catastrophic, you would have felt a little bit of heat. So I think we're in good shape, at least for now. Let's go ahead and continue with the restoration. Looks like someone put plastic tape around this. Might replace that antenna wire. That's a little janky. Okay, so now it's time to replace some of the paper caps. I'm just going to replace one here. Just gives you an idea how I roll, which everyone has their own way of doing it. This guy needs to be replaced. I read usually they have their values written on the sides. This is 0.02 rated microfarads with a working voltage of a maximum of 600 volts DC. And that is actually coming off of, it looks like that's going to the grid of this tube. That is the later added phono jack, so I don't think we need to replace that guy at all. Let's see what this guy is. Aerovox Duranite 0.01 rated microfarads. Probably a better way of saying that. That's how I say it, so whatever. So what I do when I replace my caps is I will clip one end of the old lead, pull it out of the way, and then eventually you'll get used to determining the length that you need to measure for your lead on your new cap. You want to keep it ideally as short as possible. Then I make a little hook like that in the end. You want to make a physical connection as well as a solder connection. You don't want to kind of lay stuff together. You want to make a good solid mechanical bond. I'm using a Metcal soldering iron. It's a soldering station. They're not cheap. They're about $500, but I got mine from my friend Andy. And you want to trim your end off of there, but keep it nice and neat. And where does this other end go? This other end goes to ground, and the closest ground happens to be that right here. And again, what we want to do is make a little tiny loop in one end so that we can get out of the way. Quit being a pain in the butt. Stupid cord. Alright. And then you want to wrap it around something. I swear to God, this makes for really bad video. Watching someone recap a radio. Alright, get on there. You know, like, it's when I'm filming that things don't behave. I make a jackass out of myself. So again, we want to come in here, get it real nice and hot. Make sure we get a good hot connection. A lot of people, when they first start off doing this, they will make the mistake of making their joints cold, meaning it's not hot enough and it's not a good contact. And there we go, we got that guy replaced. So just do that one more time. I'm not going to film it. Let's cut this excess out of here. And then we'll do some other things, like we're going to clean the volume pot, clean the tuning condenser. I'm going to install a new antenna wire, and then install an audio input so that someone can listen to their music on this. Okay, it's fully recapped now, and there's one other thing I need to do. This is in terms of safety and also set preservation, which is you effectively have this 90-year-old transformer sitting here with who knows what is going on with its insulation inside after decades and decades of being heated and cooled down and heated and cooled down. Sometimes they can thermally break down, and what you want is to have something in front of it that if something goes cattywampus, it's going to basically sacrifice itself before the transformer gives up the ghost. So we're going to put a fuse here between one side of the cord and the transformer, so that if this starts to act funny and it pulls more than 1.5 amps, then it's going to blow a fuse. And we're going to use something called a 1.5 amp slow blow fuse. It's spelled in a phonetic way, S-L-O-B-L-O. And it's important because the tubes, when you first, light the setup, is going to basically have an incoming surge of electrical, amperage as the filaments, fight to warm up, and then it's going to settle down. If you put a fast blow fuse in there, temporarily there's going to be a heightened amount of amperage. You could just blow it. So this guy is going to compensate for that brief moment of time when the tubes are trying to warm themselves up. So I'm going to install it right here. I'm going to drill a little hole, put this holder in there, and then the AC line will be on one side, transformer side will be on the other. And so the fuse is in between. Well, I had to take not a shortcut, had to take a break from working on radios. Our ancient Farberware convection oven had a problem. Luckily, these old appliances are as simple as apple pie, so I got it working again. Back in action. That means we can resume on more important things, like working on radios. Alright, I wanted to show something here. I was getting ready to add my audio input, which on a transformered set, usually I just go directly into the volume pot. But the more I looked at it, this is an older design. It's not a true... I'm not good with my technical terms, but basically, the volume pot is directly connected to the antenna. That means this set is acting more like a TRF. So you just can't run a signal in through here and have it do anything. It won't work that way. So what you have to do is go into the grid of the output tube. And even then, the problem is you don't get enough gain from the signal coming in. So we need to boost that signal by adding this isolation transformer. So this is a 6-volt output, 120N ratio, if that gives you an idea. And so we're running our right and left channels are tied together through a set of resistors, and that's going in through the secondary side of the isolation transformer. Primary goes to the grid 1 of number 43, which is the output tube. The other side goes to chassis ground. I know that probably makes no sense, but this will amplify the signal. It also adds a layer of electrical safety, because there's no way for the user to get any kind of voltage through the end, through this side with the Bluetooth. Alright, so we successfully have our audio running through. The only difference between this version versus going through the volume pot is you have to control the volume via the input device itself, because we're not using the volume control at all. It's going directly into the output stage, hence not attached to the volume structure. So I can't turn it up and down while I'm videoing, but when I, basically use the volume on the phone, it's fine. Well, today is really hot, and since I seem to be working on lots of appliances, I'm defrosting my 1955 Norge refrigerator, and they do not self-defrost. You got to get a fan out or a hair dryer. But since it's so blasting hot in here, it's like 90 degrees, I'm using a fan to blow 90-degree air in there, and that'll melt all the water. Anyway, not melt the water, melt the ice. Anyway, I've decided to clean the chassis. No one will ever see it, but who cares? It's nice to do anyway, including even the little shields. This is a company that made these called Goat. So Goat brand tube shields. But before I put it all back together again, I'm going to oil a few things. The tuning condenser has some bearings that need to be oiled using some zoom spout oil. And we'll get it in the back too. Also goes to the front too. All the ways. That already moves a lot nicer, feels better. Same with the volume pot. We'll get some around the shaft and it'll eventually soak in. Probably need to clean the volume pot as well. I'm not sure if I'm going to be able to do it since there's no openings in it. Usually when that happens, I just soak the crap out of it. And by capillary action, a lot of it will get into the plate area. Yep, that already feels smooth as butter. So now that we are done with the electronics, I'm going to move on to the case. But I think for the rest of the time being, I need to defrost the refrigerator. Okay, now what we want to do is clean up the case. And you've noticed I've taken the grill fabric out. It was just loosely hanging on there. And that's good because I don't want to get wax all over it. This is Bakelite. And Bakelite is actually fairly delicate when it comes to its surface. It looks like this one's not been messed with, which is good. A lot of people, when they get this, they're like, oh, that looks dirty. And the first thing they do is they take over to the sink and they scrub the crap out of it. And they remove the original casting. The casting on these are very, very, very thin. It comes out of the mold. And once you abrade that away, it won't come back. So I'm going to use a Car cleaner wax, a paste wax. I find that Meguiar's old-fashioned, whatever you call it, cleaner wax does a good job. It's plant-based, makes your hands nice and smooth. And what you want to do is just get an old rag or whatever. All my old shitty socks that get thrown away, I use those. Actually, they're my wife's socks. And you just want to get some on the old rag here. Since it's so hot today, this is coming out real gooey. You just want to do this. Kind of concentrate in one little area at a time. This takes a lot of time, actually. This takes more time than it does to actually restore the electronics. Because what you're doing is you're cleaning out and cutting through decades and decades of filth. And the idea is eventually when you get done doing this, this should look kind of shiny. Because when this came from the factory, this would look really glossy. And that would kind of add to the whole, like, quote-unquote, Art Deco streamlined appearance of this. So it's going to take a while. There's a little more detail, especially this stuff. These usually break. So I'm amazed there's no cracks in this. So this will be a neat looking set when it's done. Okay, this is generally what these start to look like after one pass. There's a lot of surface material, like a lot of just decades of grime. And so I think I'm going to have to be a little more aggressive as far as getting this off. I'm trying to do this one-handed while holding the camera steady. So I'm going to go with some Novus number 2. Sometimes you want to test it in a little area just to make sure it's not going to abrade it too much. But that will help to remove a lot of this residue a lot faster. Cut that out of there, then we can get back to the base surface and do some waxing. Alright, so this took about 2 hours yesterday. Again, I had to go over it pretty heavily with some Novus to get the crud off. And then it was on to using lots and lots of car wax. And we just brought that shine back. And, you know, sometimes it's the little details that really add up. So, for example, you see there's just a smidgen of residue left in the crack here. So I get a plastic, actually I think it's a IF transformer lug tool. I just come in here and scrape the little tiny bit of residue that's left in those corners. And I want to do this before I do the next step, because the next step is going to involve putting new grill cloth on this. At first I thought, well, maybe I can save the original. And so I gently pulled the original grill cloth out yesterday, and it's really faded and it's so brittle. The front pulled off, the back didn't make it. The back, even though I wet it down and pulled it, it just disintegrated in my hands, meaning the front and the back are not going to match now. So I dug around in my supplies and I found this grill cloth, which looks pretty believable to me. Now it's wrinkled. We can't install it like that. We need to iron it out. So I'm going to get out the old iron and we're going to iron that flat with a little steam and some hot whatever iron does. I'm not an iron expert. And then it'll be time to size, cut, and glue into the cabinet. Okay, it's time to iron the cloth. When I do is, now you got to be careful with this stuff. It's very easy to deform it and burn it. And I'm not an ironing expert, but I've generally had good success with putting it on kind of the medium-high range. And you just got to wait for the steam to start doing its thing. And by the way, I bought my own iron. I didn't want to ruin the old household iron. Yeah, it's already... We don't need much of this. In fact, I'm probably just going to do the lower half. I think we have a wrinkle. No, we don't. Okay. But I was trying to, don't stay in any one particular area. I know some people that actually iron are rolling their eyes like, no duh. Of course you're not supposed to do that. Alright, that's more than enough material that I need. But you see it's all nice and flat. I'll let that cool for a minute, and then it's going to be time to size and cut. Alright, so I've cut out the cloth, and now it's going to be the tricky part, which is getting it in here. Usually it's not a big deal, because you can just lie it on flat. And I'm trying to figure out a way to install this without making a mess. I think the best way to do it is to lay it down flat like this. And then I'm going to run some glue on this, and then I'll just kind of ease it in and fold it up around that edge there. This is always tricky, and I'm not sure if I can film it because it's going to require me getting in here with both hands, and I do not want to mess this up, so wish me luck. Alright, so I succeeded in getting it in on the front, which is the most crucial. Whoops, looks like I got a little bit of glue right there. There we go. And you can see it's uniform all the way across. So what I'm going to do is I want this to get nice and baked in the sun, so I'm going to sit it out in the sunlight and let that grill cloth get good and settled in real quick. What better purpose than to use shitty old radios that someone dumped in my yard as places to dry these. I'm going to let this sit here for maybe about 10 minutes. Again, I want to look at the alignment. And that looks very good. That's better than I thought. And the front's the most crucial. If you mess that up, everyone's going to notice. The back, I want it to be perfect too, but if I mess that up, hardly anyone's going to see it. Alright, so I've been having this sit in the sun and the glue is mostly dried. It's going to give it a few more minutes, so I'm going to bring it back in and we will glue the other side. Just trying to show you how shiny it is. Anyway, I'm going to do what I usually do with these guys and let it run for, I don't know, a couple hours at least. That'll make sure I'm bake the glue in real good and also make sure that anything that might break down thermally ain't going to do it. So that's it for this episode. Hope you guys learned a thing or two about working on ancient radios, and maybe you'll be inspired to start restoring your own if you haven't already. Alright guys, thanks so much for watching, and if you have any questions or comments, you can let me know down in the comments section, and I'll try to get to them. And until the next time something comes across this workbench, see you guys next time. Adios.